Richard Hilton teaches or taught biology and paleontology at Sierra College out of Sacramento. I've been on 4 trips with you to Northern California to look for ichthyosaurs and other anthelatosaurs. And Dick is going to give us a presentation about the dinosaurs of California. He actually wrote the book about that. And it is available. I'll plug him. He's not gonna, but I'll plug him. You can get it on Amazon. And it's a great book. I've got a copy of it. So Dick, I have made you a co-host. You should be able to share your desktop with us.
Okay, so before, should I share screen now then?
Yeah.
Okay. All right. I don't know what that did. Sure.
Okay.
How are we doing?
I can see the big Zoom screen in the middle.
Let's see. Let's see. All right. So do you see Dinosaurs of California now?
It's not centered. Okay,
Hello?
there we go.
Yeah. So we're okay? All right. Anyway, yeah, my name's Dick Hilton, Richard Hilton. I taught for 40 years at Sierra College and 6 other colleges before that. Mostly geology, but I do have a minor in biology, so I have taught biology as well. And I'm kind of an accidental paleontologist. I didn't plan to be one, but ended up by hook or by crook trying to do it anyway, which I love. So a lot of this, we're going to see the illustration. Hello? Are you guys hearing me?
Yeah, I think if you guys have a choice, put yourself on mute so we only hear Dick.
All right. Anyway, should give credit to Ken Kirtland, who was the artist that did all the illustrations in my book, a fantastic artist. While I was writing the book, he came into my office one day and told me he, did reptile illustration, and I said, well, bring me a piece, let me take a look at it. And he did, and I grabbed him by the collar and didn't let go for about 5 years. So anyway, you can appreciate his work, I'm sure. Now, we're all aware of geologic time, but just to kind of go over it again, when people talk about dinosaurs being millions of years old, they are, but they're very late in the history of life on the planet. So if you follow that red line up to the left, down to about the last fourth of the picture, you'll see it wiggles around quite a bit and goes down to the age of the Earth at 4,500 million years ago, 4.5 billion years ago. And about 3.5, 4 billion years ago, we get our first one-cell life. And there's some indicators that it might even be older than that. Maybe around 600 million first multi-celled life. So 8/9 of Earth's history is in the Precambrian, isn't it? And then we come to the Paleozoic, and we get our first fish starting about 500 million years ago. Kind of a third of the way up, first vascular plants, we get insects, we get our first amphibians, land and water creatures. And then by the end of the Paleozoic, we have lots of reptiles, including mammal-like reptiles. So a lot of time goes by before the age of dinosaurs. The dinosaur age, the Mesozoic, begins in the Triassic. I always tell my students, just think of a dinosaur with 3 butts and you'll be fine. Anyway. We get our first dinosaurs in the Triassic, pterosaurs, birds, mammals, a lot going on in the Triassic. We have virtually no evidence for that in California. Our first evidence of dinosaurs comes about in the Jurassic. And then, of course, most of the material that we're going to be looking at will be Cretaceous. the last portion of the Mesozoic. It ends, we now say, 66 million years ago. So from 250 to 66 million years ago is the Mesozoic, considered the age of dinosaurs. Now, early in the Mesozoic, we basically had one huge continent, didn't we? Pangaea. And that's a rough estimate of what it looked like. And over on the left-hand side, you see an X over the dark part, which would be the ocean, where California is at least half in the ocean for most of the Mesozoic. And that's the reason we don't have a lot of dinosaurs in California, because very few dinosaurs ventured into the ocean. There might have been one or two. And the land part of California was hot. So that's an area that's eroding. So to get dinosaurs in California, most of them had to wash into the sea as carcasses and sink to the bottom. Now here's a cartoon of the kind of plate tectonic aspect of, say, central California, but this would go pretty much the length of California up until, about the Redding area during the Mesozoic. If we start on the left, we have a mid-ocean ridge. And I'm getting a little woozy today. I gave blood yesterday, so I may have to stop here now and then, get a little dizzy. Anyway, the mid-ocean ridge, you can see the mantle below it convecting. And we all know that mid-ocean ridges are where new ocean crust is created. So on the right side of that ocean ridge, we call the Farallon Plate, it's moving toward North America. North America is moving from right to left here, away from a ridge that's beginning to occur, separating Africa and Europe from the Americas. Our little fragment there that sticks up above the ocean would be the Sierra Nevada and peninsular range of Southern California. It's eroding into the sea. And here we see the Great Valley Group, and that's going to be the Great Valley of California eventually. So Sierra Nevada on the right, the shelf area there is the Great Valley Group. Now where these two plates meet, we have a trench where the ocean floor is subducted under North America. And we scrape off the muds and sands, the goo, the oozes of the ocean floor in a trench. That's going to become the future Franciscan Formation. So far, no dinosaurs in the Franciscan. We do have a couple marine reptiles. So most of our dinosaurs are going to come from the Great Valley Group, the area that was then kind of a continental shelf. Our oldest dinosaurs in California are Jurassic. So we're going to look here at the late Jurassic shoreline. So you can see California is dissected kind of lengthwise, isn't it? The northern and central portions, if you went back to the late Jurassic, would look much like the Oregon coast today. We would have, fairly steep topography and a very cliffy shoreline at the edge between the coastal forests and the sea, which is on the left. In the lower part of California, or I shouldn't say lower, in Southern California, not Baja, but parts of Baja as well, we have an interior coastal desert that would look very much like that picture we see on the right. In the late Jurassic, we have a little bit of information on the plants. We have cycads. These are late Jurassic Monte de Oro formation in Orville. We have ferns. One of my friends has a ginkgo leaf. So a leafy forest. These are the plants that Jurassic dinosaurs might be eating. In fact, these ferns and cycad fronds may have been chewed off by dinosaurs and floated into the sea because we don't find any trunks of the ferns or the cycads, but we find abundant leafy matter like this. So these might have been actually chewed off by dinosaurs. Our first information on dinosaurs in California is Jurassic, and it comes from a desert environment in Southern California. We call the Aztec sandstone, equivalent to the Jurassic sandstones in Zion. Okay. But even deserts have life, don't they? My favorite desert to watch on TV anyway, I've been there, but it's the Namib. And to see elephants and giraffe and lions and antelope in the Namib is quite spectacular, going from oasis and stream channel to oasis. Here we have Bob Reynolds, he just passed away, as a matter of fact, showing us our only Jurassic dinosaur information from California. And these are tracts of small meat-eating dinosaurs, some of the rare meat-eating dinosaur information that we have. From the Aztec sandstone, modern dinosaur tracks on the right. Now here's the plate tectonic setting for California today. North America drifted over the East Pacific rise, the ridge that was on far out to sea in the other diagram. The Farallon plate has been consumed, and we see the ridge-like activity persisting in the basin and range. So this gives us our Grabens and Horse, the basins and ranges, fault-bounded in Nevada and on into Utah. Here we have the Sierra microplate up tilted and being shoved, trying to push its way under the Franciscan Formation on the left there. Between the San Andreas Fault and the Franciscan Formation, we see the Great Valley ophiolite. This is the old seafloor crust. This would be serpentine today. And we see those thick beds we call the Great Valley Group. Here it's called the Great Valley Subduction Zone because the Sierra Plate is trying to subduct under that portion of North America. The Great Valley is actually a trench, but it's a trench going the other way. Now you notice those beds that were deposited offshore are tilted up, as is the Great Valley ophiolite. Most of our reptile information comes from those up-tilted beds that you see right under the words Great Valley. So let's take a look. On the left, we have some of those uplifted beds. And on the right, we're in an airplane looking east at the hogbacks that form the ridges from the harder units in those up-tilted beds of the Great Valley Group. The old beds would be in front and the younger beds would be in back. So early Cretaceous in the front, late, about 2/3 the way up the picture. And then you see the flat valley floor, the Great Valley. And then in the distance, the volcano, the Sutter Buttes. And in back of that, in the far upper part of the picture below the sky, there is the Sierra Nevada. So we're going to be looking in these up-tilted beds of the Great Valley Group. Here are our oldest dinosaur remains. We have dinosaur information in the form of tracks in the Aztec sandstone, which is Jurassic. But these are early Cretaceous. My book lied, it said they were late Jurassic, but we have other information now. The one in the upper left there came from the Great Valley Group, and that came from Paskenta. And it's a foot bone of a dinosaur. I've sent it off to several experts. It's a foot bone, but it is a dinosaur. It's the earliest dinosaur, or amongst the earliest for the Great Valley Group. Strangely enough, we actually have dinosaur bones from the bedrock of the Sierra, and I would have bet against it. These are highly indurated, very hard rocks in the upper reaches of the Feather River. These are found by Jeff Christie. And we have a rib, as you can see, or the upper, the proximal end of a rib there. And on the left, we have a tooth that may be a dinosaur tooth. Can't prove it. It could also be a crocodilian. But this bone on the lower right is the only dinosaur so far bone from the bedrock of the Sierra. And these two are Jurassic, probably older than the Great Valley Group, one that we see on the left there. This is what got me interested in dinosaurs, is I was looking for ammonites, kind of west of Redding, California. And to find ammonites, you all know, you can usually find them by breaking open concretions, which I was doing. And I broke open a small concretion and there were bone fragments. And there was another concretion next to it. So I broke that open and I thought, well, that's neat, bone fragments in both. But it took me a while to find somebody, Pat Embry, to work the bone fragments out to see what they were. I thought they'd be a marine reptile. When he showed me these partially worked out, I went, no, that's a running animal. And running animals at this age had to be dinosaurs, which it was. It was a Hypsilophodon. This is a deer-sized dinosaur. Not all dinosaurs are big. These are the earliest dinosaur remains in the Cretaceous of California. And what did they eat? Well, in the same beds, we found evidence of redwoods. We found Cretaceous plants, cycads. We found ferns. So those are some of the things that some of these plant eaters probably ate. So here's Ken's painting of a Hypsilopodontid taking a drink in a lower Cretaceous forest in the Klamath Mountains. So what did terrestrial reptiles eat in the Cretaceous? So we're moving forward. We have lots of evidence. We have lots of leafy plants, angiosperms, like you see in the upper right. We have cycads, which we see in the lower right. We have ginkgos. Still some living versions of those, aren't there? And in the Sierra College area, we have lots and lots of seeds. And these are seeds of mostly cycads, but some Araucaria, the monkey puzzle tree. So cycads, we have evidence of cycads, we have evidence of ferns. There's a tree fern stem we found near the college. Equisetum, the scouring rush. There's ginkgo on the right. So lots and lots of evidence, including, like I said, Araucaria. This is a picture I took in Chile. If you want to see the Mesozoic, go to central Chile and go up to the mountains. We have a smoking volcano and huge Araucaria monkey puzzle trees. This is what the Sierra Nevada looked like here in California during the Cretaceous. In the lower right is the Sierra Nevada, complete with monkey puzzle trees, the Araucaria. But that's the Sierra Nevada, same name, in Chile. We have evidence of early redwoods, the Redenbachia, dawn redwood, lots of leafy trees, lots of conifers as well. So lots and lots of evidence for plants. We even have land snails from the Cretaceous. So from fossils, we have a real good idea of what the Cretaceous forest of the Sierra Nevada looked like. And then we have coastal environments. That's where we're going to be depositing material. And here's our first Cretaceous, late Cretaceous dinosaur. This is Ichthyornis. Ichthyornis meaning what? Fish bird. And like the Archaeopteryx, notice it has teeth. But it also has, unlike the Archaeopteryx, it has a furcula. It has that breastbone because it was a good flyer. This bone was found in the Great Valley Group, the Chico Formation near Orville by a friend named Eric Gurry. Probably a plunge diver, like a tern. So diving into the water, catching fish, using its teeth to hold on to the fish. Some modern dinosaurs. The Goliath heron in the lower left. American egret on the upper left. The crowned crane of Africa. And what's that thing on the right? That's a brown pelican. Okay, well, there are dinosaurs. There are dinosaurs up and down the state. We went a little farther north, we'd find a hadrosaur and another dinosaur that was recently discovered in Oregon. And south of here, south of California, lots of dinosaur material from Baja. I don't think we'll get to it tonight. We probably won't have enough time, but if we do, we could visit that as well. But notice from Shasta County in the north, all the way to San Diego County in the south, we have a few dinosaurs. The first dinosaur in California was found by Alan Benison, 17 years old. He lived in the town of Gustine in the San Joaquin Valley. He would ride his bicycle 35 miles one way to the Coast Range, well, to the Great Valley Group. And one of his favorite places was a canyon that he would go up. And one day in Del Puerto Canyon, he found dinosaur bones and he found mosasaur bones on the same day. This was the first dinosaur bones from the state. One way, 35 miles. When I met Alan, it was after I discovered my dinosaur and it went into the newspapers as the first dinosaur from Northern California. I got this angry phone call from Alan Benison. He says, "What do you mean you found the first dinosaur from Northern California?" I said, "Well, where's the border?" He said, "What do you mean?" I said, "Well, where does north and south end? To me, it ends at San Francisco Bay. To others, it might be at, the end of the Great Valley." Anyway, we became very good friends. And Alan took me to Del Puerto Canyon, and right above his hat there is where the hadrosaur that he found in 1937 was found. He was 82. I was younger. And he said, "Let's go up there." And I went, "Really?" I thought, this guy's going to die on the way. Well, he ran up that hill like a deer. I could not keep up with him. He was amazing. Later, myself in the middle there, Chad Stabler and Alan and I went out hunting dinosaurs together. Actually, we found part of a plesiosaur that day, but Chad Stabler has found more Mesozoic reptilian bones in California than any other person. I was with Alan the day he died. He's been gone a few years now. So this is an illustration of his hadrosaur. At the time, they thought dinosaurs dragged their tail on the ground. You know how that was. It's called a trachodon at the time. In the late 30s, early 40s, a guy named Chester Stock took crews to the Panoche Hills to look for reptiles that were originally found by ranchers, and quite successful. Here's their camp. They call it Reptile Ridge. One of the areas was in the Panoche Hills, but they went to other areas. The picture below from left to right, we have Art Drescher. I met Art Drescher before he passed away. He helped me with my book. Bob Laird died pretty young. I talked to Dale Turner and Joe Rominger. Never could find Betty Smith. That's an easy name not to find. And Clyde Warhaftig had passed away, but Clyde Warhaftig became a very famous geologist. Here they're digging up a dinosaur, a hadrosaur. And as they did in the Hazelkus limestone of Northern California, of the Shasta area, they were using black powder to dislodge rocks from the top, so they didn't have to dig so much. They don't do that anymore. They excavated this in the summertime, and you can see in the lower right, all of them, I think there's about 8 people there, resting under the tarp in the heat of the day. So here they're excavating what was to become Augustilophus morrisi. At the time, they called it Saurolophus or Saurolophus. But this is one of 2 fairly complete hadrosaurs from the Great Valley Group west of the San Joaquin Valley. Nearly complete skull with the critter. It's missing the horn. The horn was used for resonance in their call. Notice the tooth battery, very similar to Triceratops. The teeth just come in constantly as they wear. When you're eating Araucaria and cycads, you better have very good teeth. So as now, back then, it was excavation. You pedestal the samples, you burlap and plaster them, and you take them out in the rock, and then back to the lab to be prepared in the lab. Here they had the help of a mule and a sledge. Queenie the mule, by the way. Here's Ken's representation of Augustilophus morrisi, now the state dinosaur of California. I was invited by Louis Jaffe to go to the LA County Museum for the unveiling of the state dinosaur. That's pretty cool. So we had all the politicians there and many of the paleontologists. Quite an exciting event. We now have a state dinosaur named for Morris, who found most of the dinosaurs in Baja. Hadrosaurs are the most common dinosaur in California. So here we've got a jaw from near Pesquenta, Northern California. Another found by Chad Stabler down in the Panoche Hills, and still another in the Point Loma Formation of San Diego on the right there. Well, speaking of San Diego, we have 2 maps here. The map on the left shows what it looks like in California 20 million years ago. And I put a band across the area to show where the units dinosaurs would be found in. And then as we drifted over the mid-ocean ridge, the East Pacific Rise, the continent begins to be torn apart. And the Baja Peninsula is rifted off of Mexico and slid through transform faults, including the San Andreas, north. So that yellow area now, part of it is in the San Diego County, and the other part goes south about 125 miles into Mexico. That's the area where dinosaurs have been found in California and Baja. A very complete ankylosaur was found by Brad Riney in the Carlsbad area. This is just north of San Diego. He was monitoring for paleontology in a road cut here, and they turned up quite a bit of bone material. It turned out to be a fairly complete ankylosaur. There's Brad Riney right there in the right, working in the San Diego Natural History Museum. Brad passed away about 2 months ago, unfortunately. And they're working behind the, what they call the bubble there, on the fossil in the San Diego Natural History Museum. Elitapelta coombsi. Elitapelta coombsi was named for a paleontologist, Walter Coombs, who was a specialist in ankylosaurs. They're kind of the armored tank of dinosaurs. Lots of scoots all over their body and plates, and with ridges and horns, and then this wrecking ball of a tail. So where are the meat eaters? We saw a couple small ones in the footprints in the Mojave, but the only meat-eating dinosaur was found by a fireman by the name of Pat Antuzzi. He brought me this bone and asked me what it was. And I said, I don't know, I have no idea. It's a big bone. I kind of doubt it's a marine reptile because of how thick the bone material is. I said, it looks like it might be a dinosaur, but I can't prove it. Well, a couple months later, I contacted a paleontologist from Florida, and he was a specialist in bone osteology, and said that he could maybe tell what kind of dinosaur it came from in a broad sense. His name's Greg Erickson. So he asked me to send him thin sections of the bone, a longitudinal section and a cross section, which we did. And about a month later, I went into my office and there was a message. So I pressed the button and it was him. And he said, Dick, I think I got a holopod. What did he say? Click. Dick, I think I got a holopod. I thought, what? It sounds like a sauropod. And I thought, I don't think they have sauropods in the late Cretaceous. They're very rare if they do. And I said, I wonder if it's a theropod. Anyway, it was a theropod, a young theropod, and probably an Albertosaurus, if I had to guess, because they do find Albertosaurus from all the way from Alaska to Mexico. So we've got kind of a Tyrannosaurid type here. That's our only meat-eating dinosaur remains. So here is a, whoops, try it again. Here is a painting of the ancestral, let's say, American River with redwood trees, palm trees, whoops, ginkgos. Huh. Well, you find palm trees with redwood trees. And the answer to that is yes. If you ever go camping at Samuel P. Taylor Park in Marin County, there's a redwood forest there. And guess what's growing in the redwood forest? Is a palm tree. And we do find ginkgos and palms and redwoods in the same flora. So they did grow together during the Mesozoic. But we've also got some pterosaurs, which we find in California. We've got Ichthyornis lying in the foreground. We've got Augustinolophus morrisi in the foreground here. This is Cretaceous California. Alan Benison gave me this, and I've used it in every talk I've ever done. Repent, the Cenozoic is near. And the meteorite hits the Yucatan Peninsula. So that's it, unless you want to see more on Baja, but that's it. You said give me 20 minutes to half an hour. I think I did a half an hour there. So hopefully that's what you want. What do I have to do? Undo something?
You unshare.
Okay.
And there we are, back again. So, questions?
Whoops, where'd he go?
Well, I can see you now.
You can see me? I don't know what happened to you. Let's see.
Yeah, we're back. Yeah, if you.
Oh, there you are. I got you.
Yeah, there we go.
Yeah, go ahead with the questions.
Yeah, most people are muted. If you want to talk, take yourself off of mute. Otherwise, we can't hear you.
Well, first of all, my computer is really slow, so I still had the Cretaceous explosion up. But my question is, how much time do you have left on the Baja material?
Oh, 10 or 15 minutes. I could.
Because that might be another meeting if you're willing to come back and visit with us again that we could talk about.
Well, I was thinking if I did this again, I'd do the marine reptiles.
That too.
Yeah. And that would be a slightly longer talk. That'd be a longer talk, but
we're up for it.
Okay. So anyway, I'd be happy to do either one or both.
All right, I just want to say first off, thank you for the talk. My question is kind of a two-part question, but they kind of go together. What would you say the main questions are right now for California dinosaur paleontology, and where do you see the future of dinosaur paleontology in California going?
More specimens. They're very, very rare.
Rare.
And where it's going, and right now it's going nowhere other than people are working out more of the taxonomy on what we have. But it's really going nowhere because we have no due specimens.
You could just as well ask what's going on with Oregon dinosaurs, and there's not much there because we only got 2 specimens.
Yeah. You know, when I did this book, I was starting out just to do a pamphlet, and didn't think I'd find much. And then I decided to do all the reptiles, and then it got to be bigger. And then I owed so many people so much time and energy that I thought, well, I'll do a book.
Greg, do you have the book handy to show us what it looks like?
I was looking for my copy and I could not find it. However,
I bet Richard has it.
Yeah, Richard's got one there.
It's UC Press. It's old. It's 2003. If you buy it, you probably have to buy it online for a lot of money. I don't know. I don't know if you can get them cheap anymore. I'm not trying to sell books anymore. So.
How do we get it with your autograph on it?
You could mail it to me or come down, and I'd be glad to put my autograph on it.
Okay, thank you.
I had a question about avocados.
What's this about avocados?
Well, I had heard that avocados had to have been eaten by large animals because the seed is so big that there aren't any existing animals that can swallow them. Have you ever found any fossils of avocado seeds?
No, I haven't. And I doubt that, they were there in the Mesozoic. But for avocados, you're probably looking at giant ground sloths and mammoths and mastodons. Those kind of organisms would be more likely to have eaten them whole like that.
Okay.
This is Jerry Aaron and Mr. Hill. I was looking at the, trying to remember the map, of course, and you saw where the, when the San Andreas started crumbling off and one part going north and one still kind of going the other way. And of course, in the Baja, a much wider and probably much larger area of search there. And then that small swath that has moved north up into that Pinocchio, whatever it was, area or east of Modesto.
Oh.
And
the small
we're looking right there. Go ahead.
The small swath moved up to San Diego. San Diego.
Okay, that was San Diego.
Baja.
It's not for the north there.
Yeah, yeah. And Baja's got a significant amount of dinosaurs and very interesting ones. But probably not enough to do a whole talk on, but I could include it in something else.
Yeah. So is Luis Chape, is he working with any of the Mexican and or other paleontologists, or is the university down there, San Diego or whatever, working in that area?
He does quite a bit of work in Argentina.
Yeah, I know he did. I got some interest, there too. But not in Baja.
There have been some plans to go to Baja. I don't know if they were able to work it out with the Mexican government. But, if you go down and work in Mexico now, I think all the fossils have to remain in Mexico.
In Mexico, yeah. Makes sense. Yeah, thank you.
You're welcome. Other questions?
This is not related to the dinosaurs, but perhaps a teaser for a future talk on the marine reptiles. Greg has shared a lot with us about the ichthyosaurs that he's been prepping and that helped you find. What is your leading line of research right now regarding those specimens?
Well, I'm working with other scientists that know a whole lot more about marine reptiles than I do. But we're basically trying to take all those fragments that he worked on, and we haven't yet, assembled to see if a lot of them go together or a few of them go together. We know there's, a couple here and there that go together, but I think we're going to be able to see a lot more of that critter. It's unfortunate that we don't have more of the skull, because that's really what you need to figure out what the heck you've got, But Neil Kelly is doing most of the science on that. He's from back east, Vanderbilt University.
Yeah, Vanderbilt. This is Jerry Dodson again, and like I say, this is on that ichthyosaur and small blocks that Greg brought over and I'm working on. But one of the things I was interested in, and you'll probably get into it coming back and talking about, especially up in that area, in the Shasta area, is the nature of that Panthalassa reef system and like the depth of those particular reefs, because I think they were fairly shallow and reefs as such are fairly shallow. I'm trying to learn a lot about, as much as I can, about reef systems, and especially from a paleo standpoint. So I got a lot of stuff to read and a lot of stuff to learn, of course. And I find that really fascinating in looking at the matrix in regard to the bones. And I have, as Greg has seen, some centrums, etc. But I'm looking at sponge and what I think is the bryozoan, and then looking at an extremely a friend at Kutztown University. I sent him a slice or a piece of the matrix, which had a layer, and it was a really dark layer, but hardly a millimeter thick. And I've gotten some micrographs, SEM micrographs of that material, which is looking at extremely even what I think are cyanobacteria because of the size of the items. But and I'm really interested when you come back in, and if there's discussion of the reef itself, because that's these bones just seem to be, you know, fairly scattered, and what I'm looking at's really the ones here really eroded, and that could be a result of the erosion up in that area anyhow, and the lots of perking and water perks.
Well,
so
we have
anyway, I shut up now. I'm just interested in it.
Basically, this is a beach environment that's eroding, a present beach on Lake Shasta that's eroding the fossils. So they were probably much better preserved in the rock, but if they got exposed by wave action, some of them have been eroded quite a bit. Others, the ones he's working out, are beautiful. So it's quite a treasure trove.
Yeah.
Nothing's been done like this in 100 years. It's been since John C. Merriam was working there in 1906, 7, 10.
Wow.
It's the last time anybody found anything this complete.
This is Greg. I brought this one in. This is one of the bones in question. This is actually the best part of the backbone that we have found. And I prepped it. I brought it to the NARG group back around Christmas. This thing's about 20 inches long there. And it's been sitting up here at my place because we can't get down there due to COVID. The college is closed.
Yeah, that's a bummer.
Yeah.
Yeah, actually,
we know that this section goes, it has another piece that this whole section's at least 40, 50 inches long of these articulated backbones.
Yeah.
4 feet.
Yeah, Russell's coming here tomorrow. I'm going to give him a bunch of my publications.
Yeah. So yeah, if you guys didn't see it when we had it at the NARG group, here's one example. This, of course, is a great example of the bones we were getting out of Northern California. And I understand now we have another site to go dig in, different than where this one came from. If we ever get to go back into it, and if we ever learn how to live with poison oak.
Yeah.
Prednisone, I guess.
A good poison oak attack may be worse than COVID for some people.
Tell us about it, Aaron, if that occurs.
Doug, do you want to share what you discovered, or can I share it?
Doug Olson.
Yeah, it's on the chat. You just look at the chat.
Well, I just thought it was kind of funny. Doug, you must have done a search while we were talking.
I did.
Go ahead and share it. It's funny.
Well, it's saying there's you can get Mr. Hilton's book on Amazon, used books, for about $10.
Really good.
Yeah, you can pay $521 on biblio.com. You don't get to share in that, do you?
No. You've got to be a big fee to get on that?
To get on which? Biblio.com?
Yeah.
No, I looked at, I found them on bookfinder.com.
Great.
It usually summarizes everywhere you can find a particular book.
He was just saying somebody has it for sale for $521 if you want to spend that kind of money. And he was joking that he didn't think you would get any of that 521.
No. Okay.
So,
I get it.
Anyway, it's a good catch. So it's out there.
That's great. That's great.
I guess I had a side question since, again, another teaser. With all of the marine reptile parts being found, if you were going to make a pie chart of the terrestrial reptile or archosaurs, whatever we want to call them, versus the marine, what percentage of what's been found so far is dinosaur versus marine reptile?
If it's just the state of
Yeah,
California,
just California.
just the state of California, it's probably about 2/3 marine reptiles.
Okay.
Is there another question? I'm not hearing it.
It's about 4-2 on marine reptiles and dinosaurs from Oregon.
Oh yeah, okay.
Does that include the pieces that Andrew found and the ichthyosaur that Bill Orr collected some time ago? That was more like 7 or 8 specimens.
We have that many ichthyosaurs? I thought
Not just ichthyosaurs, I meant marine reptiles. Because we've got.
Well, that's true. We do, if you count the Thalattosuchia.
Yeah.
And
The
Bernie.
plesiosaur, the
Plesiosaur. Yeah.
and the croc.
Yeah,
Well,
it's
that's
probably
a
about
Thalattosuchia.
7 or 8. You're right.
Yeah, it may be as many as 10 to 2, something like that. But not as many as California has found total. 10 total specimens. Other questions from anybody else?
Okay, well, I'd just like to say thank you to all of you. I really enjoyed this. And maybe I'll come back and do another one day.